Here we go. So tomorrow, which is Friday, we will have a quiz. It's on graphing. Okay. Well, let's take a look at page 85. I haven't marked it off yet, or that's what I just marked off. You passed up 79 and 80 already. Less than you. All right, so page 85, we are just graphing these, right? So let's review before we go over how to do this. So when we are graphing these, you want it in this form, right? So if it's not in this form, if it's an example that's like this, y equals x plus 2 times x, then multiply that over and you get this. Okay? So go with all that, all right? So then if you're graphing it as well, then once you have this up there in this form, do x equals negative b over 2a, which finds us our axis of symmetry. And then once you do that, find your vertex, which is negative b over 2a, plug in. Okay? And then after that, you can pattern graph, which is a times 1, 3, 5, really. And if your a value is 1, then it stays 1, 3, 5. And if your a value is like 7, then your 1, 3, 5 becomes 7, 21, 35. Okay? Also, if it's negative, it makes those negative. Right? That's everything we've done. Things that I'll be looking for, make sure you have your axis of symmetry. That's just that vertical line. Make it just a vertical dotted line. Okay? Sometimes you'll be able to find the roots. Sometimes you won't. You won't be able to find the roots if your vertex happens above the x-axis and your parabola opens up. Or you can't find your roots if your vertex is below the x-axis and your parabola opens down because it doesn't cross. Okay, those are called complex solutions. So if you had graphed your parabola and it looks like this, and they ask for, hey, what are the solutions? Your answer is just complex. That's the same if your parabola looks like this. It does not cross the x-axis, so it's complex. Those are both complex scenarios. Agreed? There's other times, though, that your solutions, you just can't tell. So there's other times where you can see that it crosses there and there, but you don't know exactly where it is. Okay? So that happens when you cannot factor your trinomial. You can't factor it, it won't go. Okay? We good with that?
And that's irrational.
So yeah, these would be irrational if it didn't factor. Now, don't go and put that you have irrational. Hey, yeah, buddy. So don't go put irrational every time you can't see. You're not quite sure if it factors or not. I mean, you learned how to factor, so factor it. Okay, don't just go put irrational. Even if your 1, 3, 5 doesn't cross right away, take a look at it. See if it factors. Okay? All right, so now let's take a look at page 85. What problems do we have there? Yeah. Number 5, that's a good one. Now, you won't see one like number 5 tomorrow, but this is a good one. It's y equals what?
Y equals 1/2 x squared plus 2x plus 4.
Plus 4, like that?
Yep.
Okay. So this one looks a little different because we have a fraction out front as our a value. Agreed? So if I were to look at this, I know my a value is 1/2, which that's 0.5, right? My b value is 2, and my c value is 4. Okay. Why do you think I'm changing the 1/2 to 0.5? Yeah, we can have, so when we go try and find our axis of symmetry, AOS, that is x equals negative b over 2a, right?
Will we be given that formula or should we?
I would say know it. We do it all the time. We say it all the time. So negative b, so negative 2 over 2 times a. If a is 0.5, we can do that. So what's 2 times 0.5? 1. Thanks. It's just 1, right? So what's 2 over 1? What's 2 over 1? Just 2? Okay, so axis of symmetry, right? That's the first things up there. Do I know the whole thing of the vertex, or is there something I have to do?
Plug in.
Yeah, I gotta plug in 2 here and here. So 2 squared is
4.
4. Half of 4 is
2.
2. Plus 2 times 2, which is 4, plus 4. So 2 plus 4 plus 4 is 10. So 2 comma 10 is way up here. Did I do that all right? Are all my signs good? Ooh, I made one error. Does anyone see it?
No.
Made an error. Anyone see it? It is. Yeah, that should have been a negative right there. So negative 2 squared is 4. So that 2 works. That should be negative 8, or negative 4, excuse me. Negative 4. That'll work. So 2 minus 4 is negative 2. Negative 2 added to 4 is positive 2. So negative 2. Oh, that changes a few things. That's not my axis of symmetry. My axis of symmetry is over here. Sorry about this. Boy, I tell you, first problem I do all day, I goof up. It's going to be a long day. So negative 2 comma 2 is right here. Is that all right? All right, so if I pattern graph, the 1, 3, 5 has to do with the a value. What's my a value? 2. What's my a value? 1/2. So my pattern graphing is going to be 1/2, 3 halves, 5 halves. So I'm going to go right 1 up half, left 1 up half, right 1 up 3 halves, which is 1/2, so I'm going to get to right there. Left 1 up.
Will we have a problem with this tomorrow?
I won't have a fraction up front. But that fraction out front, if that fraction is between 0 and 1, it makes your parabola real fat. But that's number 5. All right, let's move off 5. See what else we have as questions up through 9. Yeah.
Question number
7? Okay. Perfect. Number 7 says y equals negative 2x squared minus 12x. Is that it? Plus, minus 7? Okay. So my a value is negative 2, my b value is negative 12, c value is negative 7. Hiccups right now. My axis of symmetry, AOS, is x equals negative b over 2a. X equals negative 12 over 2 times a. What's negative 12? Positive 12. Positive 12 over negative 4 comes out to, I think, negative 3. Is that all right? Let me pull up a grid. X, Y axis, some images. So I think we can plot our -3, our axis of symmetry, -3, -1, -2, -3. Is that all right? My vertex exists somewhere on that line. So I know my vertex is -3, comma, I need to plug it in. Okay? So -3 squared is? -3 squared? 9. 9 times -2? -18. Okay. -12 times -3? Positive 36, because negative times positive. Times that. So -18, -7 combined together to give me -25. 36 minus 25 is 11. So -3, comma 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Eesh. Did I do that right? What's this pattern graphing as? Is it 1, 3, 5? What's my A value?
2, 6,
Careful.
negative.
-2, -6, -10. Okay? So from here, I'm going to go right 1 down 2, left 1 down 2, right 1 down 6, 1, 2, 3, 4, 5, 6, left 1 down 6. Hey, do you think I can squeeze 10 out of that?
Yeah.
Yeah, let's do it. Right 1 down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, quick question. 0, comma C. Is that my y-intercept? What's our C value? So 0, comma -7. That should be our y-intercept. So let's see. -1, -2, -3, -4, -5, -6, -7. Boom. Boom. Worked. Love it. That's a great problem.
Can we find our roots? Or not?
I don't know if that'll factor. Let's see. If we were to factor, I'd say 14. Factors of 14 are 1 and 14 and 2 and 7. There's no way I'm going to get to that -12. So, but did you see how quick I just went to see how quick it was? I didn't go write down all the factors. So, I know I have a degree in math, so shame on me that I can realize that 1 and 14 and 2 and 7 are the factors. But doesn't 3 work? Yeah, it does sometimes. Any other questions off of this? Any other questions? Yeah. Number 9?
Yeah.
Before I go to number 9, quick question. Do you have enough information to tell me what that point is, and that point, and this point, and this point, and this point, and this point? Like you can tell me what they are as ordered pairs? If I give you a grid each time, do you think you could do that? Especially when you pattern graph? You feel good about that? Okay. That might be a subtle hint. It might be a problem tomorrow that it says, hey, find us the vertex plus 4 other points. Well, there's the vertex and 6 other points, right?
And you need at least 4 to graph it, right?
Well, you want 5 to graph. You want the vertex and then two other sets of points. 9 you said? 9?
Yeah.
Okay. What does number 9 say?
Y equals x, parentheses 2 minus 6.
Okay. Hey, this is a great one. This is a great one. This problem tells us a couple of things. This problem here tells us a couple of things. This tells me I have a root at 0, 0, and I also have another root at 2, 0. How did I just do that?
Because you have 2 x's.
Yeah, is this factored form? So I can go x equals 0 and 2 minus x equals 0. So that's x equals 2. So that gives me 0, 0, root, 2, 0, root. I have root and root. That's nice when that happens, yes? What will happen exactly in between 2 roots? The axis of symmetry, which then would lead us to find the vertex. Does that make sense? Holy cow, hang on. Let me bring up my grid. I think we can do a whole lot with this problem.
Because the line of symmetry will be 1, 0.
Yeah. All right, so because it was set up in this form, which is really cool, you're just setting each binomial equal to 0 and solving it. I got 0, 0 right there, and I have 2, 0 right there. Halfway in between those is 1. So my axis of symmetry has to be right there. Agree? So that means my vertex is going to be 1 comma something. Hey, did I figure out negative b over 2a? I did indirectly. I used logic to say, hey, halfway between these 2 points I know exist has to be that axis of symmetry. That axis of symmetry is always the x component of my vertex. And then, how would I find this?
You could just plug it backwards.
You can plug it in if I want. So I get 1 times 2 minus 1. What's 2 minus 1? 1 times 1 is, what's my vertex? 1 comma 1. Wait a minute, Mr. Sharp, this one looks like it's going to open upside down. But your x isn't negative. Oh, hang on, let me distribute. Boom, boom. X times 2 is 2x. X times negative x is negative x squared. Is my a value negative? Yes or no?
No.
The a value goes with which term?
Oh.
X squared, x, or the constant?
X
X squared. What's my x squared lead coefficient? Negative 1. Okay? So it should open it. Our pattern graph should continue. So this, look, that worked. Right one down one, left one down one. Right one down 3. Left one down 3. I could keep going if I wanted to, but I definitely can see those points. That's number 9. Any others you want to take a look at from that homework last night? It was nice. You didn't have a ton of homework. It was like, okay, I can kind of take a little bit of time. Yeah.
Have you already done number 8?
I don't know. Did I do 8? I didn't do 8, but I'm happy to do it. Number 8. So we have y equals, and I know I'm changing all the f at x's, and it means the same thing. Is that x squared plus
2x.
2x plus 1?
Yep.
Okay. Hey, quick question. Just by looking at it, does it look like it might factor? Anyone have any idea what it factors to?
1 times 1.
X plus 1, x plus 1. What do you think? Yeah, do your magic number. Does this factor to x plus 1, x plus 1? I think so. I think this is a perfect square trinomial. Well, wait a minute. I just did a problem that if it was broken up into that, that told me where a root is. So where's my root? Where's my root? Huh? Nope. So I get it. So I have to set my roots equal to 0, so I get x plus 1 equals 0, so x has to equal what? Negative 1. But I have the exact same thing. What the heck does that even mean? Negative 1 right there. There's a root. There's only one of them, but I have 2 binomials. Is it possible to have the parabola's vertex lie on the x-axis? Well, if it's not possible, I don't know how the heck to do this problem then. Right? So, because this is a perfect square trinomial, you get one root. What can you guarantee me that root is then? Starts with a V. Ends with an X. Vertex. Okay, if that's the vertex, that means my axis of symmetry has to be right here. So my axis of symmetry is x equals negative 1. My vertex is negative 1 comma 0. Okay, it factored out. Now if you're like, oh, wait a minute, you said negative b over 2a has got to be the way to do this. Okay, well, let's take a look. So I get negative 2 over 2 times 1, which that's like, you know, such a different number. You know, negative 2 over negative, or negative 2 over negative, or over 2 is negative 1, and negative 1 is equal to negative 1. And if I take negative 1 and plug it in, because you're supposed to go there and there to get the y component, so I get negative 1 squared plus 2 times negative 1 plus 1. Well, that's 1 minus 2 plus 1, which is 0, which is, it works. whole lot of ways we can go to this. Hey, pattern graphing, 1, 3, 5 work? Absolutely. All right, right one up one, left one up one, right one up 3, left one up 3. Is that enough points? I think so. You probably could go up to the 5 if you wanted to, but looks really well. Hey, that means that if we did this right, 0, comma c would be my y, where it crosses the y-axis. So 0, comma c, what's my c value? Does 0, comma 1 exist on our graph? Uh-huh. Cool, cool stuff. Wow. Anything else you want to see off that homework? Yes. I don't know. I'll do it though.
Okay.
Number 4 says what?
2x squared
So y equals 2x squared
minus 8x
minus 8x
plus 5.
plus 5. Opens up, right? Some people might say, well, is this one factor? Well, let's take a look. 5 times 2 is 10. The factors of 10 are 1 and 10 and 2 and 5. Is there any way that 1 and 10 and 2 and, or 2 and 5 could add up to be negative 8?
Wait, 1, 2, and 5? Or
No,
just 2
1 and 10 or 2 and 5.
Oh, no.
Nope. So it's not factorable. Okay. My A value is 2, my B value is negative 8, and my C value is 5. I think we're going to have to use x equals negative b over 2a to find us our axis of symmetry. Yes? So I'm going to get negative 8 over 2 times 2. Negative 8 is positive 8. 8 over 4 is 2. Okay, so my axis of symmetry is 2. So I get 2 comma something. So I'm going to plug 2 in there and plug 2 in there. 2 squared is 4. 4 times 2 is 8. Negative 8 times 2 is negative 16 plus 5. So that's negative 8 plus 5, which is negative 3, right? I think I got enough information to graph this, I think. All right, let's take a look. X equals 2. That's there. 2 comma negative 3. 1, 2, 1, 2, 3. It's right there. Pattern graph. Is pattern graph 1, 3, 5 or something else?
2, 6, and 10.
Yeah, it's 2, 6, and 10 because I multiply that by my A value. So I'm going to go right one up 2, left one up 2, right one up 6. 1, 2, 3, 6. Left one up 6. That should be plenty. Wait a minute. Where crosses the y-axis is 0 comma c, and 0 comma c would be 0 comma 5. And that would mean that that needs to be 0 comma 5. So let's see. 1, 2, 3, 4. It is. Wow. We're there. We are there.
Do number 6. That's
Yeah.
all negatives.
Oh, it's all negatives?
Yeah.
Heck yeah. Can I move off this one? Can you read me number 6, please?
So negative 2 squared minus 8x minus 4.
Like that? That's a good one. It's going to open down because you got that negative in there, right? If you have negatives all the way through, I'd say don't even try and worry about if it would factor. Okay? If it does factor, it'll probably expose itself to you when you're graphing it. So on this one, my A value is negative 2, my B value is negative 8, and my C value is negative 4. So I get x equals negative b over 2a. So I get x equals negative 8 over 2 times negative 2. Oh my gosh. All right, let's see. Negative 8, positive 8. 2 times negative 2, negative 4. What is 8 over negative 4? Negative what? Negative 2. So that's my axis of symmetry. So negative 2 comma something is going to be with this. So if I plug negative 2 in there, negative 2 squared is? Negative 2 times negative 2 is? 4. 4 times negative 2, negative 8. Negative 8 times negative 2, positive 16, minus 4. Negative 8 combined with negative 4 is negative 12. 16 minus 12 is 4. I think we got enough information to start graphing this bad boy. What do you think? Come on, baby. All right. Axis of symmetry is what? -2, right? -2, 4. 1, 2, 3, 4. Opens down. Does 1, 3, 5 pattern graphing work on this one? No, why not? There's a -2, so that's -2, comma, -6, comma, -10, or slash. Okay, so I'm going to go right one down 2, left one down 2, right one down 6, 1, 2, 3, 4, 5, 6. Left one down 6, right there. That means that 0, comma, C is going to be where it crosses the y-axis, and I know my C value is -1, or -4, excuse me, so 0, -4, 1, 2, it worked. It worked. Huh. So, yesterday we talked about jumping off a cliff into a lake. I gave you a personal account of a story, which using, and this won't be on the quiz, but distance equals 1/2 AT squared, where A is the acceleration of gravity. We know that the acceleration of gravity is either -9.81 meters per second squared or -22 feet per second squared, because we understand feet a lot more, right? But we're going to talk about one little other thing, and then we're going to just see how this works. Stopping distance. Okay? So if you would, make sure your names are on those sheets. Pass those on forward. But we're going to also talk about stopping distance of a car or a motorcycle or a bike. So have you ever wondered how the police figure out how fast someone's going after a car accident? Ever thought about that?
Cameras from like distance to light.
Cameras, okay. Cameras would be pretty valuable these days.
Well, like the time they go from one light to the next one.
Okay. So if anyone gets into a car accident, you probably don't. If you're you survived and you're competent after the accident. If you were to if you were somebody who ran into somebody else, and let's say the speed limit's posted 55 miles an hour, you as a driver, well, how fast were you going? Well, I was doing like 52, right? You're not going to tell the officer, yeah, I was doing 78 miles an hour in a 55. You're going to BS them, right? Agree? Why is that? Well, it makes us human. We don't want to get in trouble, right? Even if we did something wrong, we're going to try and massage the truth so we don't get in trouble. Agree? So even with anti-lock brakes on pavement, there is initial stop mark, and then if this is the crash, anti-lock brakes, your brakes go like this. They go stop, 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 stop. They don't stay adhered to the entire time. But if you hit them hard enough, there's an initial where you hit your brakes, and then if you got into this accident, what they're going to be able to do is they're going to say, okay, this is the distance to impact, okay? Because obviously if you hit your brakes initially, you're not like, oh, we're going to run into it anyhow. Let's take my foot off the brake and, I don't maybe crawl in the back seat or something. Accidents happen quickly. The human reaction is, oh no! Or if you're a parent, oh no! You're trying to hold your family back with your arm. Oh, that hurts so bad. Right? So that's your reaction. It's not hit the brakes, oh well, we're going to hit. I'm just going to cross my arms and hope for the best. you're going to hit, so you have a certain distance. Now, every automaker has a certain crash. If this is your crash front end of your car, there's a certain amount of damage that does incur. And that can go, they make cars right now to be crushable. They absorb the impact of either themselves striking a stationary object or striking another car. Okay, why did they do that? Because that allows the energy to be released in the crushing zone of your car, which means you don't go flying through the windshield. Or you don't have the bruise on your shoulder from, you didn't break your collarbone and 4 ribs because your seatbelt. I mean, your crush zones are what you want. But it all really comes down to talking about this distance there. And so, if you just kind of think about this, this is what the parabola looks like. Now, this part of the parabola we ignore because we're not going negative miles per hour, are we? How fast you going? Doing -7. Really?
Going nothing.
Okay. And then if you're going 0 miles per hour, your braking distance should be 0 feet, right? But then as we go, you find all of these points along here. And so what they can do is they take a look at your braking distance, and they can figure out, oh, okay, well, this down here is miles per hour, and this here is distance in feet. The police already have it converted, so you can relate feet to miles per hour. If not, you can go distance in miles per hour, which is silly or distance in miles, because your braking distance probably isn't going to be in miles, unless you're doing 1,900 miles an hour and you hit your brakes, which you probably won't go that fast. So what the police officer does is they realize, oh, okay, distance in feet. So here's how far that skid was. The impact did something, so they're going to come over here and they're going to say, oh, okay. Oh, it gives us in miles per hour. And sir, you said you were doing 52 and a 55. Oh, that's correct. Well, it's funny because the physics behind your skid says you were doing 78. Oh, that's impossible. Well, physics doesn't lie. Why would a police officer lie when he's doing the math? I'm not saying people don't lie, but I'm just asking. Well, why?
I said, why wouldn't he?
Why would a cop lie, or why wouldn't he lie?
Why wouldn't he? You said, why would he? I said, why wouldn't he?
Well, I'm just curious. I mean, do you feel that this would be a made-up distance and this would be a made-up distance? I'm curious. I'm not trying to say that there's not bad people out there in the world. I'm just trying to say, is the physics, if I gave you these distances, is the physics going to be different? Because physics will not lie. Physics will not lie. Physics will not lie. Is physics a police officer?
No.
No.
Really?
So, if I have a distance here and a distance here, and I know the crushability by the manufacturer, will the manufacturer lie saying, oh, the crush zone, if it's this far deep, we're just going to make up information? I don't think the car maker is going to do that. I mean, if they do, I'd say that engineer is not there. So, this is called extrapolation of data. And this is how math works. If this is a parabola, this goes with this, our general equation. It goes with that. But physics doesn't lie. People do. I agree with that. Who's all lying on the scene of an accident? The person who caused the accident, right?
No.
Yeah. Usually both of them.
Yeah, a lot of people. There could. So I bet you we could all agree on this. If some accident does occur, we'll just call it ACC for accident. You have this person who is in one car, this person in the other car, right? Do both of the people tell the exact truth that happened? Is the truth somewhere in between the conversation? It depends. It could be outside of it, right? They both could be fibbing. Or they both could be exaggerating. Right? Right? Yeah, oh yeah. And then you got old Johnny Law who shows up here. That's the police. And they are supposed to, I'm just saying, right? Supposed to take into account these two statements and any other statements that took place by people who saw it. Yeah.
Me and my cousin, we were driving on the back roads behind Southlands.
Yeah.
We were going about 120.
Oh yeah.
And there's all these hills, so you can't tell whether this is a car or not until you were like actually right next to it. So we go over this hill and we're coming down. We're about to go over a hill, and we see a car right here. He tried to stop, and the car flipped. And the officer was like, "What were you doing at your speed?" And he was like, "Oh, just 55." He was like,
Is everyone okay?
He was like, well, by the looks of the car was totally destroyed. He was like, it seems you're going on over 90.
Yeah. Well, I mean, the thing is, if you're doing 10 miles an hour, are you gonna flip a car over?
No.
You could, but physics won't lie. In a traditional driving environment on flat pavement, the probability that you flip a car over doing 10 miles an hour.
You can flip a car just by trying to just turn a little bit.
What?
So,
And you know, if you have like 8 people on one side, and
So,
you know that's
yeah, if you have an external force that's acting upon the car, absolutely. But if I were to go out in this parking lot, I could drive in circles doing 10 miles an hour all day long, and then turn my wheels as hard as I could, and I guarantee my car won't flip over. Now, it's probably not good for the tire wear, but I guarantee I won't flip the car over.
My dad gets really mad at me when I take like super sharp turns when I'm driving.
10 miles an hour, though.
So
10 miles an hour. I'm walking at 10 miles
no,
an hour
and
right here.
my dad would.
Guaranteed.
That's not 10 miles.
10 miles an hour? Maybe 7. Right?
And then once we go
I'm old. I can't walk fast.
Oh my gosh, wanna know what is so scary? My brother used to longboard,
Yeah.
and we have this like,
That's so
you know, like it like watches your speed and like it tells you if you're going like too fast or not. My brother would drive his longboard down that, you know, like the hill in front of my house. Yeah, he'd ride that down on his longboard and he'd make like 25 miles an hour.
Wow.
So scary.
So,
I hate when he did it.
here's a little cool thing. So, do you guys know what the Porsche 911 Carrera looks like? If not, you need to look it up. You want to know what's fascinating about the Porsche 911? You want to know what's the most amazing thing about the Porsche 911? So it's kind of shaped like this as a car. Now I'm not a great artist, but this is the shape to the car. You want to know the fantastic thing about a Porsche 911 Carrera? The center of mass. The center of mass is 9 feet underground. What is the center of mass? The center of mass is this. If I take any object and I throw it, it will rotate around its center of mass. Okay, I take any object and throw it. Like I can't get this pen, if I throw it, I can't get it to rotate around the end. It rotates around its center of mass. If I throw myself, I can rotate around the center of mass. Hey, how does a gymnast change their center of mass? Or a diver? Yeah. Yeah, you move your arms, tuck, all kinds of things. You bring your legs in, you change your center of mass. Where's your center of mass as you're standing there? Between your belly button and your pelvic bone. Okay? Now it gets goofy with kids growing because sometimes you grow faster, but when you become a stabilized height, your center of mass is between your belly button and your pelvic bone. Okay? Porsche 911 Carrera. Center of mass is 9 feet underground. You want to hear the most amazing thing about this car? Now this car, you'll get it, it'll slide. You can make it slide. But if you were to take a corner at 120 miles an hour, all 4 wheels will stay on the ground. You cannot flip this car over. Center of mass, the physics of the car, how's it designed? Can't. Huh? Because it's pretty expensive how the physics of the frame works.
It
But isn't that pretty cool?
It hugs the ground super well.
That's why. So this goes along with like race cars. Like, why does a NASCAR flip over? It had another object act upon it to push it. But. All right, so page 87, page 88. Page 87, 88 is what I want you to do for tomorrow. We do have a quiz tomorrow. We do have a quiz tomorrow.
You spelled my name wrong.
I did?
No.
Have a great day, everybody.